Euclid's Element, Book 1. Propositions. Proposition 32. In any triangle, if one of the sides be produced, the exterior angle is equal to the two interior and opposite angles, and the three interior angles of the triangle are equal to two right angles. Let ABC be a triangle, and let one side of it, BC, be produced to D. I say that the exterior angle, ACD, is equal to the two interior and opposite angles, CAB, ABC, and the three interior angles of the triangle, ABC, BCA, CAB, are equal to two right angles. 4. Let CE be drawn through the point C, parallel to the straight line AB. By Book 1, Proposition 31. Then, since AB is parallel to CE, and AC has fallen upon them, the alternate angles BAC, ACE, are equal to one another. By Book 1, Proposition 29. Again, since AB is parallel to CE, and the straight line BD has fallen upon them, the exterior angle ECD is equal to the interior and opposite angle ABC. By Book 1, Proposition 29. But the angle ACE was also proved equal to the angle BAC. Therefore, the whole angle ACD is equal to the two interior and opposite angles BAC, ABC. Let the angle ACB be added to each. Therefore, the angles ACD, ACB are equal to the three angles ABC, BCA, CAB. But the angles ACD, ACB are equal to two right angles. By Book 1, Proposition 13. Therefore, the angles ABC, BCA, CAB are also equal to two right angles. Therefore, etc. What was to be shown? Proposition 33. The straight lines joining equal and parallel straight lines at the extremities, which are in the same directions, respectively, are themselves also equal and parallel. Let AB, CD be equal and parallel, and let the straight lines AC, BD join them at the extremities, which are in the same directions, respectively. I say that AC, BD are also equal and parallel. Let BC be joined. Then, since AB is parallel to CD, and BC has fallen upon them, the alternate angles ABC, BCD are equal to one another. By Book 1, Proposition 29. And, since AB is equal to CD, and BC is common, the two sides AB, BC are equal to the two sides DC, CB, and the angle ABC is equal to the angle BCD. Therefore, the base AC is equal to the base BD, and the triangle ABC is equal to the triangle DCB, and the remaining angles will be equal to the remaining angles respectively, namely, those which the equal sides subtend. By Book 1, Proposition 4. Therefore, the angle ACB is equal to the angle CBD. And, since the straight line BC, falling on the two straight lines AC, BD, has made the alternate angles equal to one another, AC is parallel to BD. By Book 1, Proposition 27. And it was also proved equal to it. Therefore, etc. What was to be shown? Proposition 34. In parallelogrammic areas, the opposite sides and angles are equal to one another, and the diameter bisects the areas. Let ACDB be a parallelogrammic area, and BC its diameter. I say that the opposite sides and angles of the parallelogram, ACDB, are equal to one another, and the diameter, BC, bisects it. 4. Since AB is parallel to CD, and the straight line, BC, has fallen upon them, the alternate angles, ABC, BCD, are equal to one another. By Book 1, Proposition 29. Again, since AC is parallel to BD, and BC has fallen upon them, the alternate angles, ACB, CBD, are equal to one another. By Book 1, Proposition 29. Therefore, ABC, DCB, are two triangles having the two angles, ABC, BCA, equal to the two angles, DCB, CBD, respectively, and one side equal to one side, namely, that adjoining the equal angles, and common to both of them, BC. Therefore, they will also have the remaining sides, equal to the remaining sides respectively, and the remaining angle, to the remaining angle. By Book 1, Proposition 26. Therefore, the side, AB, is equal to CD, and AC, to BD. And, further, the angle, BAC, is equal to the angle, CDB. And, since the angle, ABC, is equal to the angle, BCD, and the angle, CBD, to the angle, ACB, the whole angle, ABD, is equal to the whole angle, ACD. By Book 1, Common Notion 2. And the angle, BAC, was also proved equal to the angle, CDB. Therefore, in parallelogrammic areas, the opposite sides and angles are equal to one another. I say, next, that the diameter also bisects the areas. 4. Since AB is equal to CD, and BC is common, the two sides, AB, BC, are equal to the two sides, DC, CB, respectively. And the angle, ABC, is equal to the angle, BCD. Therefore, the base, AC, is also equal to DB. And the triangle, ABC, is equal to the triangle, DCB. By Book 1, Proposition 4. Therefore, the diameter, BC, bisects the parallelogram, ACDB. What was to be shown? Proposition 35. Parallelograms which are on the same base and in the same parallels are equal to one another. Let ABCD, EBCF, be parallelograms on the same base, BC, and in the same parallels, AF, BC. I say that ABCD is equal to the parallelogram, EBCF. 4. Since ABCD is a parallelogram, AD is equal to BC. By Book 1, Proposition 34. For the same reason also, EF is equal to BC. So that AD is also equal to EF. By Book 1, Common Notion 1, and DE is common. Therefore, the whole, AE, is equal to the whole, DF. By Book 1, Common Notion 2. But AB is also equal to DC. By Book 1, Proposition 34. Therefore, the two sides, EA, AB, are equal to the two sides, FD, DC, respectively. And the angle, FDC, is equal to the angle, EAB, the exterior to the interior. By Book 1, Proposition 29. Therefore, the base, EB, is equal to the base, FC. And the triangle, EAB, will be equal to the triangle, FDC. By Book 1, Proposition 4. Let DGE be subtracted from each. Therefore, the trapezium, ABGD, which remains, is equal to the trapezium, AGCF, which remains. By Book 1 Common Notion 3. Let the triangle, GBC, be added to each. Therefore, the whole parallelogram, ABCD, is equal to the whole parallelogram, ABCF. By Book 1 Common Notion 2. Therefore, etc. What was to be shown? Proposition 36. Parallelograms which are on equal bases and in the same parallels are equal to one another. Let ABCD, EFGH, be parallelograms, which are on equal bases BC, FG, and, in the same parallels, AH, BG. I say that, the parallelogram, ABCD, is equal to, EFGH. 4. Let BE, CH, be joined. Then, since BC, is equal to, FG, while, FG, is equal to, EH, BC, is also equal to, EH. By Book 1 Common Notion 1. But, they are also parallel. And, EB, HC, join them. But, straight lines, joining equal and parallel straight lines, at the extremities which are, in the same directions, respectively, are equal and parallel. By Book 1 Proposition 33. Therefore, ABCH, is a parallelogram. By Book 1 Proposition 34. And, it is equal to ABCD. 4. It has the same base, BC, with it, and, is in the same parallels, BC, AH, with it. By Book 1 Proposition 35. For the same reason also, EFGH, is equal to the same, ABCH. By Book 1 Proposition 35. So that, the parallelogram, ABCD, is also equal to, EFGH. By Book 1 Common Notion 1. Therefore, etc. What was to be shown? Proposition 37. Triangles which are on the same base and in the same parallels are equal to one another. Let ABC, DBC, be triangles on the same base, BC, and in the same parallels, AD, BC. I say that, the triangle, ABC, is equal to the triangle, DBC. Let AD, be produced in both directions to, E, F. Through B, let BE, be drawn parallel to, CA. By Book 1 Proposition 31. And, through C, let CF, be drawn parallel to, BD. By Book 1 Proposition 31. Then, each of the figures, ABCA, DBCF, is a parallelogram, and they are equal. 4. They are on the same base, BC, and, in the same parallels, BC, EF. By Book 1 Proposition 35. Moreover, the triangle, ABC, is half of the parallelogram, ABCA. 4. The diameter, AB, bisects it. By Book 1 Proposition 34. And, the triangle, DBC, is half of the parallelogram, DBCF. 4. The diameter, DC, bisects it. By Book 1 Proposition 34. But, the halves of equal things are equal to one another. Therefore, the triangle, ABC, is equal to the triangle, DBC. Therefore, etc. What was to be shown? Proposition 38. Triangles which are on equal bases and in the same parallels are equal to one another. Let ABC, DEF, be triangles on equal bases, BC, EF, and in the same parallels, BF, AD. I say that, the triangle, ABC, is equal to the triangle, DEF. 4. Let AD, be produced in both directions to G, H. Through B, let BG be drawn parallel to CA. By Book 1 Proposition 31. And, through F, let FH be drawn parallel to DE. Then, each of the figures, GBCA, DEFH, is a parallelogram, and GBCA is equal to DEFH. For they are on equal bases, BC, EF, and, in the same parallels, BF, GH. By Book 1 Proposition 36. Moreover, the triangle, ABC, is half of the parallelogram, GBCA. For the diameter, AB, bisects it. By Book 1 Proposition 34. And, the triangle, FED, is half of the parallelogram, DEFH. For the diameter, DF, bisects it. By Book 1 Proposition 34. But the halves of equal things are equal to one another. Therefore, the triangle, ABC, is equal to the triangle, DEF. Therefore, etc. What was to be shown? Proposition 39. Equal triangles which are on the same base and on the same side are also in the same parallels. Let ABC, DBC, be equal triangles, which are on the same base, BC, and on the same side of it. I say that they are also in the same parallels. And for let AD be joined, I say that AD is parallel to BC. For if not, let AE be drawn through the point A, parallel to the straight line BC. By Book 1 Proposition 31. And let EC be joined. Therefore, the triangle ABC is equal to the triangle EBC. For it is on the same base, BC, with it, and in the same parallels. By Book 1 Proposition 37. But ABC is equal to DBC. Therefore, DBC is also equal to EBC. By Book 1 Common Notion 1. The greater to the less, which is impossible. Therefore, AE is not parallel to BC. Similarly, we can prove that neither is any other straight line except AD. Therefore, AD is parallel to BC. Therefore, etc. What was to be shown? Proposition 40. Equal triangles which are on equal bases and on the same side are also in the same parallels. Let ABC, CDE, be equal triangles on equal bases, BC, CE, and on the same side. I say that they are also in the same parallels. For let AD be joined, I say that AD is parallel to BE. For if not, let AF be drawn through A, parallel to BE. By Book 1 Proposition 31. And let FE be joined. Therefore, the triangle ABC is equal to the triangle FCE. For they are on equal bases, BC, CE, and in the same parallels, BE, AF. By Book 1 Proposition 38. But the triangle ABC is equal to the triangle DCE. Therefore, the triangle DCE is also equal to the triangle FCE. By Book 1 Common Notion 1. The greater to the less, which is impossible. Therefore, AF is not parallel to BE. Similarly, we can prove that neither is any other straight line except AD. Therefore, AD is parallel to BE. therefore etc. What was to be shown?